Alrighty then. This is an example of an IB question that's actually easier than a test question that we would have. Although, some of these are kind of weird, right? So state why F, this is the friction force acting up the plane, right, is the only force providing a torque about the axis of the cylinder, right? So why is that? Well, they're talking about a torque about this point, right? That's the axis of the cylinder. The central axis is what they really should say. And remember that torque is RF, right? And R is how far you are from that point. Notice that these forces are actually exerted at that point. So the reaction force is exerted that way. The force of gravity is exerted this way. And so R is actually 0 for those forces. Yet this one's exerted out at the edge at some distance, right? And it is not at R equals 0, okay? Anyway, yeah. And then we've got this whole thing here, right? And they say show that it's this, right? So again, we're just going to start with mg sine theta is ma plus I alpha over R, right? And I felt like I should show where that comes from. So that comes from torque is I alpha, right? So torque is RF. That equals I alpha. By the way, in the mark scheme, you don't have to show that, but I just did, right? So therefore, F is I alpha over R, and this is the force needed to accelerate it, right? Okay, so now we're set. Now we can plug this in, right? And what you're going to do is plug in 1/2 mr squared for that. This is going to be A over R. And then you can simplify that, right? So you know how to do that. Plug that in. And then the only thing you don't do that we do is you don't need to make the substitution for sine because they're not telling you any lengths here. They're just going to give it an angle, okay? So you're going to leave it in terms of sine, okay? Let's take a look at the next page here. And then it says, calculate for theta is 30. Well, even if you didn't get letter I, don't feel like you can't do this one. We can do this, right? So just use it, right? So the acceleration is, even if you couldn't show that this was true, use it in this part, or you'll lose these points, right? These points. So A is 2/3 times G times sine of the angle, right? So plug that in, right? So 2/3 times 9.81. The sine of the angle is 1/2, right? Okay, but if you're going to use 30 degrees, right? Sine. Make sure you are in degrees, right? That should be 1/2, right? And then just calculate that. I got something between 3 and 4 meters per second squared. And then suvat that. I think you're going to use S is equal to UT plus 1/2 AT squared. Okay. Suvat that for the time. And the time is between 1/2 second and a whole second. Okay. I will tell you that much, right? Then it says, part C says, a block of ice, and the ice is going to slide down the cylinder, right? It's a block, so we imagine it maybe as a cube. Both are released at the same time. Well, the block is going to just slide, right? It's going to just translate. So mg sine theta for the block, right? Mg sine theta is going to be ma. Well, hey, A is just g sine theta. It's all of g sine theta, whereas when it rolls, it's 2/3 of g sine theta, right? So use that to explain this answer, okay? When it rolls, it has to gain what? Translational and rotational kinetic energy. If it slides, it gains only translational kinetic energy. That's another way to explain it. Not sure that was on the mark scheme, though, so I guess you better stick to the accelerations. And then D, a solid cylinder. Well, the solid cylinder for the solid is 1/2 mr squared, right? For a solid cylinder. For a ring, I thin ring is what they're talking about, is mr squared, okay? And so I did this whole complicated thing, like I did the whole substitution and showed that it was, I think it was 1/2. You end up with 1/2 g sine theta. You don't have to do that. I looked at the mark scheme. All I have to do is say, this has a bigger moment of inertia. So then is it going to accelerate faster if it's got a bigger moment of inertia, or more slowly if it's got a bigger moment of inertia? Okay, so answer it that way. Okay, I hope that helps.